Hey students, in the last video we talked about the concept of limiting an excess reactant. So in this video we're going to calculate how to determine which reactant is the limiting reactant. So we're going to start on page 6, number 1. So let me pull up my annotate tool here. It tells us that we're reacting 5 grams of hydrogen with 5 grams of oxygen to make water. So hydrogen is H2. Oxygen is O2, and we're going to make water. So we have to balance this. So we have to have a 2 here and a 2 here. So when you're trying to determine which reactant is the limiting reactant, what you're going to do is you're going to do 2 stoichiometry conversions. So we're going to start with our 5 grams of hydrogen, and we're going to go to grams of our product. So we've got grams of hydrogen here. We need grams of hydrogen down here. We need to use the molar mass, so that's 2.02. Molar mass is always equal to 1 mole, so we put 1 mole on the top here. We don't use the coefficient yet because the molar mass has to be equivalent to just 1 mole of that. We're not at the grams of our product yet, so we have to keep going. And remember, you've got moles, and you have to have moles again down here. This is where you're going to use your coefficient to switch between your 2 substances. So we'll have 2 moles of hydrogen here. We'll have 2 moles of water up here. We want to go to grams though. So we have to have moles of water down here. Remember, we can only use that coefficient 1 time. So we'll have a 1 here because we're trying to find the grams of water. And grams is always equivalent to 1 mole. The molar mass of water is 18.02. So we're going to go ahead and solve this one. We got 5 divided by 2.02 times 2 divided by 2 times 18.02. And we should produce 45 grams of water. So for our second stoichiometry sequence, we're going to do the same thing, but we're going to start with our other reactant. We know we have to do a limiting reactant problem when it gives us the quantities of both reactants. So same kind of thing. We have to have grams of oxygen down here. We have to use the molar mass. That's equal to 1 mole up here. Now, since we are in moles of O2, we have to have moles of O2 down here. And we're going to use the coefficient. So this is a 1 because the coefficient of oxygen is a 1. We'll have 2 moles of water up here. And I've got moles of water, so I have to have moles of water down here. It has to be a 1 because we've already used the coefficient, and we'll have the molar mass of water back up here on the top. So I have to go to the same place. I have to take both of these stoichiometry conversions to the same location. In this case, grams of water. So I calculate how much grams of water the oxygen should produce, and that should be 5.6 grams. Once you do both of these stoichiometry conversions, what you're going to do is you're going to compare these 2 values here. You're going to compare the 2 that were produced by each of the reactants to see which one was the limiting. Which one are you going to run out of first? Well, hydrogen can make 45 grams of water, but oxygen can only make 5.6 grams of water. So that means that oxygen is going to be the limiting. Whichever one produces the least is your limiting reactant. And when it asks how much water is produced, well, whichever one of these is lower, the 45 grams of water or the 5.6 grams of water, that's how much water is going to be made. Because once we're done with the oxygen, once all the oxygen is used up, we cannot make any more water, okay? So it's got to be the 5.6 grams of water is how much is made. That would be our answer down here. All right, let's take a look at the next question. This one says if we add 10 grams of magnesium with 10 grams of water, 10 grams of oxygen, what's the maximum amount of magnesium oxide that can be produced? So we've got magnesium, and we have oxygen. I don't know why there's that random line there that just popped up. Whoopsie. Let me try to erase it. I don't know. And it's going to make magnesium oxide. So to balance, we have to have a 2 here and a 2 here. This time we're starting with 10 grams of each reactant. So we have 10 grams of magnesium. So that means at the bottom of this conversion factor, I'm going to put what? Grams of magnesium. And the number that goes with grams is my molar mass, 24.30. So the molar mass is always equal to 1 mole. 1 mole of magnesium up here. We have to remember, go to the grams of our product, because we're trying to determine the maximum amount of magnesium oxide that can be produced. So we'll use the coefficients here so that we can switch from moles of magnesium to moles of magnesium oxide. And then we had to have moles of magnesium oxide down here, remembering that we can only use that coefficient one time. So this is going to be 1 mole. And up here, since we have grams, we need to find the molar mass of magnesium oxide. So that's 40.3. So we'll go ahead and solve. And we should be making 16.6 grams from the magnesium. So we'll have to do the same thing starting with our oxygen. So we're going to have grams of oxygen down here. It's going to be 32 molar mass of oxygen. We're going to use 1 mole here because we always put 1 mole on top of molar mass. We have to switch from moles of oxygen to moles of magnesium oxide. So we're going to use our coefficients, 1 and 2. And we have to have 1 mole of magnesium oxide down here. So we're only going to use 1 mole to equal the molar mass of our magnesium oxide, which we've already calculated to be 40.3. So let's calculate this. 10 divided by 32 times 2 times 40.3. And we'll have 25.2 grams of magnesium oxide. So you compare these two values again, how much was produced just based on the magnesium, how much would have been produced by the oxygen, to see which one makes less magnesium oxide. Since magnesium makes less magnesium oxide, the magnesium is going to be our limiting reactant, and our amount produced is going to be how much ever the magnesium produced, so we'll make 16.6 grams of magnesium oxide. Because remember, once we run out of magnesium, we don't have any more left to react with the oxygen, so we can't make any more than 16.6. All right, I'll go over the next problem in the next video, so if you need to hear it again, but that's limiting reactants.